Welcome to How to Write Assembly Language on the VIC-20. Wait, no, this isn't the right course. Well, it's kind of like that. It's JavaScript, so it's almost the same feeling, you know. I'm Ken Rimple. I work for Chariot Solutions. I'm the guy that was talking his head off in the morning, doing training and mentoring and all sorts of different technologies. Mostly these days, I've been doing nothing but Angular. It's like all year, pretty much. And so this kind of came out of a couple things. ECMAScript 6 is at the heart of what Angular 2.0 is going to be. We got Kent C. Dodds. He was in here a second ago. And he came out to talk about Angular 2. He was at the NGConf conference as well as me. And he's very connected with that community. So it was good that we got someone directly connected to the people on the Google team to speak about Angular. I'm like, great, I'll step back from that this year. And then because Angular 2 is so focused on ECMAScript 6, I figured I'd probably better pay more attention to it and bring up what the tools are for people here. How many people here now are trying to work with ECMAScript 6 in their code? That is a safe answer. Okay, still, if you've done HTML5, how many people here use HTML5 in their browsers? All right, now, put your hands down if you did that 4 years ago. Yes, see, there we are. So, in other words, not that many people are able to quite yet take advantage of ECMAScript 6 directly. What we're going to talk about in this particular chat is we're going to go through just a little bit of a review on some of the ECMAScript 6 features to get your appetite whetted a little bit, in case you weren't in the earlier talk about that. Won't take a ton of time on that, but give you a feel for what's coming. And then we're going to go into how you can apply ECMAScript 6 now, kind of like you do with CoffeeScript, generate code that runs in ECMAScript 5 from ECMAScript 6. Or on some platforms, run it natively. So this is going to be a talk that just kind of covers all the bases of what's available now. I'm doing exactly what Dave, the pragmatic programmer, said don't do, which is give you stuff to work with tomorrow. Hey, why not? And I was laughing my head off as he went through all the things to try because he mirrored exactly what I had to do to get this talk ready. So I didn't go down the grunt route, but almost everything else in that list except the first and the last thing is somewhere in the kitchen sink of this talk. Slides are online, and they will be up on the Philly Emerging Tech site and a link under the speaker notes, but that's the link to them. And I'll leave the last slide up at the end so you can grab the link if you'd like as well. There will be, in that same folder later this week, I'm going to upload all my projects so you guys can play around with this stuff too. So you'll have a zip file to download for all of that. So we're going to start off with this review of ECMAScript 6. Talk about where we are now in the different browsers and support, find out some of the tools we can use to figure out what's going on. Then we're going to look at the browser, and then we're going to look at the server. So that's kind of the sweep of the hour. So what is ECMAScript 6? Who was in the ES6 talk yesterday? Half of you. Okay, which is fine. So here's the short answer. It's the new version of JavaScript. ECMAScript being the official name of JavaScript in the standards body. That's all it is. And so ECMAScript 6 is the next evolution of JavaScript. The last evolution of JavaScript that was major was ECMAScript 5, and that was in 2009. So it's due for an update, right? It's due for language upgrades. And then from what Alan Wersbrock said yesterday, they are now going to try to get on a yearly, basically minor release cycle for changes to the ECMAScript language. Knowing browsers the way I do and knowing how slow browser manufacturers are to get anything to agree, you're probably looking at several years before some of these things roll into most of the major browsers. Just another show of hands, who here is stuck on IE8 or IE9? So you're going to have to do something like this for the time being, because there's really no choice. You can't run native ECMAScript 6. You've got to find a way of running some sort of trans-compiling thing, which we're going to talk about, or emulating it somehow. All right, so right now, you're looking at it just starting to get traction in browsers, just starting to get traction on Node, and things like that. And there are a ton of new features, such as, this is the only cheesy Star Trek joke I had, so I'll go with it. So one of the features is full class support. So this means we can create classes, we can create extensions of other classes, we have constructors, and we have simpler method syntax. It's just syntactic sugar. In the end, it's still prototypical inheritance. That's really what you're getting out of it, but it's a nicer way of describing it so you don't see so much code. So that's one good thing. If you took a look at any of Angular 2's talks, they spend a lot of time talking about how they're doing everything with class definitions. So you'll define an Angular 2 component as a class, and then they have some additional things called annotations on top of those that come from a compiler called Traceur that has the ability to add like metadata to your classes. So that's where that first started showing up in a lot of people's minds. But this is one of the big enhancements from a syntax perspective, is the class syntax. And you do a new of it just like you do a constructor. And the way it works basically is instead of calling a function that looks like a constructor, you now call, when you do a new, it calls constructor for you. Otherwise, it's the same thing. Next thing, local variables and constants. I forgot the constant. That was helpful of me. But it's const, C-O-N-S-T. Right now in JavaScript, if you've programmed enough of it, you realize the crazy nature of the fact that the var really doesn't actually define the variable in the line of code you think it does. Right? If you put a var inside of an if, it did not define the symbol in the if. It defined it at the top of the function it was defined in. So you have function level scoping, object property scoping, and global scoping, and then you're done, right? And one of the things that they talked about yesterday in the JavaScript talk was the fact that they couldn't just make the var keyword suddenly work with blocks for scope. So for example, in that if statement down there, if they decide to make that if statement actually encompass a variable and they called it var, they would break keyboard cat, right? All the old web code that's out there would suddenly cease to exist. So they had to come up with a new keyword essentially, or a new token, so it's now let instead. Let works in a block scope, which is really nice because now I can have variables inside of ifs, inside of while loops, and I don't have to play those games and worry about whether they're still, initialized and used at the bottom of the block, or I access them wrong. It actually has lexical scoping that makes some sense. Also, they've added read-only variables, constants, const, C-O-N-S-T, and they're also scoped at the block level as well, if I remember correctly. Arrow functions, this is their answer to things like we have in Java now with lambdas and other things. This is their shorthand syntax for defining an anonymous function. So it's just syntactic sugar. It's not like you're getting any new technical feature beyond making it look nicer. So we've got, instead of the word function, you can just put the parentheses in. Instead of the braces, if it's a single line statement, it could just be an arrow equals greater than, and then a statement that does something. That's a one-liner. Of course, I had to make it 2 lines to fit on the slide, but hey, such is life. But the point being, I can use that in a for each. Of course, I see a lovely syntax error in that where I never close the for each, but why not? It's a slide. But the idea is you could basically iterate through and do a simple anonymous function with a lot less code. If it's multiple lines, you put braces around it as usual, so it's a little less terse. But arrow functions are pretty useful. The other thing you get, and you can't see this here, but this is a backtick. And this should also be a backtick. It did not get done properly. That's a backtick, okay? Is you get these strings that have the flexibility of using templates like you do in Java, $brace, for example, in Ant and things like that. So I can say, for each of these values, do a console log and output val property A dash val property B. You don't do that currently in JavaScript, but it must use backticks, not single quotes, not double quotes. So sorry for the numerous typos here. I'm working on that now. Multiple line strings were not valid in JavaScript unless you put backslashes at the end. And even then, sometimes the browser couldn't deal with it. If you use the backticks, strings can be multiple lines now as well. So if you want to embed a small template in a fragment as a string, you could now do that without all sorts of string concatenation and pluses. So that's another nice little thing. So it's good. Another cool things are now default parameters. So you can now say parameter name equals and a default value. If it's not provided, it will get whatever that value is. You can also have a REST parameter, and that's not REST in terms of web services, that's the rest of the stuff. And this basically turns into an array. So at the end, it has to be the last thing in your function, but you can say ... whatever, and then you can walk through it. I also wanted to show you this. Who's done for in? For in iterates through the keys of an object or the indices of an array. For in brings the items back as a name. So instead of having to go and reference them by index again or by property name, you just directly deal with the element that comes back. So again, these are all nice little features they're starting to bake into JavaScript as a language, and they're at the language level. It's not like I have to go find a compiler. except for the fact that your browsers aren't ready to do this yet, right? Most of them, if they do anything, they kind of half-roll the features out. Destructuring is another interesting one. Syntax here, it's a really dumb example, but let's say we had an object called A, and it had a property B and D, right? Two properties. You could define two variables and pull them out of the properties of A named B and D, and it will pluck those out by property name and make them local variables. This is used a lot when you use imports, when you use modules in ECMAScript 6. You can say, I want to grab these 4 things from the module by their name and import them. So it's one of the ways you'll see it used is in this curly brace syntax. There's a keyword called import that they do the same thing with. So destructuring is another one of those interesting little features. When now we actually have sets and maps, right, and true arrays. So we've got the ability to create a set, add things to the set, see whether it has an item in the set. Same thing with a map, set and get and has. Okay, and so they work the same way they do in other languages. So instead of using object for almost everything and array for everything else, now you actually have true dedicated constructors to create those things as well. Promises. Promises is a technology that everyone's starting to go down this road of having the ability to kick off something asynchronously and then get a handle back to resolve the answer later in JavaScript. In Angular, we use promises all over the place for asynchronous calls to the web or running a timer and getting the result when it comes back. But this lets us natively in the language create a promise. So let's say up top you had an API, and that API was going to do something, and it was going to do something asynchronous. We don't know when it's going to get done. We know we want to hand back something to the caller and then resolve the answer later. So that return new promise says, okay, I'm going to return this promise thing, and the promise is going to have embedded within it a method that it's going to dynamically create for me called resolve, another one that I'm calling reject, and that's by convention they're the first and second arguments to the promise. I'm also, if you notice, using an arrow function to find this thing. So instead of doing a nested function like you normally would, I'm shortening a little by using an arrow function. So this is just like saying function resolve reject in here. It's a callback. So when the promise is ready to be run, it's going to execute this thing. And as I'm doing my work, when I'm ready to give an answer back in the called API, I call resolve and I pass it the thing. If it fails for whatever reason, I call reject and I pass it whatever I want to pass as the payload for a failure. So that's in what I'm calling. The caller, it will actually execute this thing, and let's assume this is called API call that returns this promise. And then there's a method called then on every promise. And in then you have 2 functions you can provide, one for the successful result, one for the error result. And now you have a way to chain that information back. And I'll show that to you towards the end when we look at a Node Express app that's using ECMAScript 6. I have it so that it's actually bringing back data through a promise. So you can see that in action. If you've done any Angular, this is relatively familiar. The nice thing is it'll be part of JavaScript itself. So one less thing that has to be non-native to work with long term. Generators are the one that I wrap my head around a little bit too late in the game, but basically generators have the ability for you to kind of start a function, put it to sleep, and pick it up again, and pass data back and forth to the caller. The best way you'll see these used is in iteration. So on APIs that support true generator-based iterators, that thing up top is emulating that. So we're assuming we've got some sort of list that has 3 things in it, right? It's got basically 3 strings that come back, apples and oranges and cereal. And the way we know it's a generator is we put a star at the beginning of the function. And by using the star at the beginning of the function and by using the yield keyword, we're able to suspend and get information back from that function in the caller whenever we're ready for it. So each yield can be accessed by next on the iterator, right? So if our function shopping list is called, it returns an iterator. And then we can keep looping and just do iterator.next. And each time we do next, it's going to get the next yielded value. So this is a really arbitrary example, but it's baked into the language. So anything that will bring back iterated results will have this thing. And what they do is they bring back an object for each iteration, and the object has two properties. One is called done, which is false all the way through till the end, and then it goes true when it's finished. So that's our indicator whether the iterator is finished. And the second property is the value, whatever we're actually putting in from the yield. And that's the new thing in generators. So in general, generators should be a pretty interesting way of basically going through and iterating through structures in a common way across the API. So those are some of the things that are coming in ECMAScript 6. But let's think about practicality now. Okay, what is supported right now? And so if you haven't seen this, if you do a search for Kangax, don't do it now, .github.io, there's a compatibility table here. Oops, and I did it on the wrong screen, so bear with me here. There we go. Yeah, that looks about right. See all the red? What we have here is we've got a bunch of different features along the side that could be supported, and a matrix along the top of all the different browsers and runtimes that might or might not support them, and your little, color-coded map of red, nope, right, failure of support, yellow, partial support, and green, mostly supported. And you'll notice that most everything in the real browser world doesn't support a whole lot, right? i.e. technical preview supports a fair amount of ECMAScript 6, but who's using that right now in production? Probably no one. Also, if you look at IE 10 and 11, forget it. Don't even bother with IE 9. Firefox is the closest in terms of supporting things, but there are some big holes in some of this. For example, even with classes, I could not get Firefox Nightly to natively create a class. So it's, okay, great. When are you guys going to get around to getting ECMAScript 6 working? And it's just because it's just like HTML5 about 4 years ago. That's where we are right now. Browser companies are going to start rolling in these features in the next couple releases. So realistically, you're going to have to do something to turn the code that you like in ECMAScript 6 into runnable ECMAScript 5 code if you want to program in a way that you can then just kind of eventually flip a switch and natively run your code in ECMAScript 6. Now, do you want to do that? It's up to you. But basically, you have the option of writing code in ECMAScript 6 syntax today. Code, tests, server-side code if you do Node. And there's some tricks we use. So in some cases, you can get browsers that are native, and in some strange, weird places, like you can run Firefox Nightly in your own internal app, but that's probably unlikely. More likely, you're going to use some sort of feature in the browser or some sort of build feature. So for example, a shim, some sort of script you load that says, I want to emulate ECMAScript 6. That's one way to do it. And another way to do it is to run a transpiler, which is a really fancy name for a cross-compiler down to ECMAScript 5. All right, so that's really what we're talking about there. We're going to go into that in the next section. And then at the end, the server side, you have a few more options, mainly because unlike the website where you've got 30 browsers or whatever to deal with, you've got Node, and a couple other options on the back end that you want to pick from. So as your runtimes upgrade, it's just the server. There's one thing to deal with. So you have a few less things to think about. All right, so let's look at ECMAScript 6 in the browser. As long as it actually plays nice. Hold on one second. I need this, or I will not be able to do my work. There we go. All right, so in the browser today, let's just fire up. I'll show you what it would look like with Firefox Nightly here. So this is the nightly edition of Firefox. I just updated itself, so that's a great idea for a demo. Okay, so but now in here you can see at the very, very bottom. Actually, let me see if I can get this to be a little bit more. Where is it on there? No, we'll live with this. I'm going to say, and this happened to me before too. There we go. Some weird bug with when Firefox Nightly decides to let you type. All right, so I'm going to say var myfunc equals x arrow x times 100. So that's an arrow function. And now I can do myfunc 213, and I've got 21,300. Yeah. Do functions in ES6 have implicit returns, or is it only the arrow functions? So it's only the arrow functions that I know of that do that. And also, if the arrow functions have more than one line of code, it doesn't seem to return anything either. No, no, it'll be undefined unless you actually specify a value. So, for example, if I go back and redefine this, well, you know what? I don't believe myself sometimes. I have to test my theories. Yep. So if you put a code block around it, right? If you put a curly brace around the whole thing, all bets are off, no return value for you, right? But if you don't, and if it's just a single statement that returns a value, that's the return of the item. So, you know, neat. But if I go in and I say class, now watch, this will make a liar out of me. Customer, I love hurting myself. It's just fun that way, right? Class customer, let's just do it without anything in here. Class is a reserved word. So you can't do that natively in Firefox. Other things work, you know, but not everything. And so you go back to that Kangax table, you say, oh yeah, I have to do some funky thing, like maybe I have to call it in a function in strict mode. There are some things you have to activate that way. And to me, it's like, I don't have time for this. I got a job to do. So, you know, clearly you're not going to say, let's push this up to the enterprise. Everyone go up and load Firefox nightly. It's just not going to happen. So anyway, let's look at this, a couple different ways to do this kind of thing. Again, dynamic transpilation, where we do it in the browser without a build step, and also these transpilers. All right. And, you know, the slides are a little silly. I call it transpilers. That is the term of these things. They're all transpiling something. First one we'll look at is Babel. Is it Babel? I think it was Babel. And Babel is an open source project, babeljs.io. Has a number of flags and options you can flip on and off. It's very configurable. And here's the website for it. You know, they have a little try it out thing. So you can kind of, you know, play around with the language a little bit. So console.log, I am in ES6. And it's then we use strict, not in a function for some strange reason. It's printing out console log in there. So it's modifying things and turning them into ECMAScript 6 syntax. If we did an arrow function, for example, we could do that. But I couldn't do a demo without writing a little bit of code. So I have one called Code Mangler. And in this one, it's just a little Angular app that loads a JSON file that points to a bunch of code samples. And I pick a particular code sample, and then I can click on Transpile. And so what this is doing is it's calling a JavaScript API from Babel to transpile this into another string, which I then throw over to the right. So let's look at what this little function is doing. By the way, executed as well. So let's see if I can fold this and take a look at this. We have a console log printing out an array.from. Now this one is kind of interesting, actually. I went with a tough one first. That array.from takes two parameters. First parameter is kind of instructions for how to go through something. So if you give it an object with a length on it, it will loop that many times and call the thing inside of the from in the second parameter, which we've done as an arrow function. And so in that one, it will pass us two things. I'm not sure what the V is. It's probably some sort of context. But the second thing is the actual key that's been passed for the iteration. And so using that and then closing that up, we get this nice little output of, 0, 1, 2, 3, 4. Great. To do that in the current browser, we have to have it translate this or transpile it. And so all they really had to do, all it thought it had to do, was call array.from and expand the arrow function into a real function. So that's one of the things Babel will do. It will take the code, look at it, and say, well, arrow functions don't exist in ECMAScript 5. So we're going to go ahead and generate a regular function and expand out the syntax and just do it as a regular function call. That's pretty straightforward. Here's the thing that's not so straightforward about transpilers. The transpiler doesn't know your browser doesn't have the from method on array. Right? That's a sideways thumb right there. That's like, great, thank you, transpiler, you don't know about the API change. But array.from was added in a recent update to the JavaScript API as part of really ECMAScript 6, I believe. And not all browsers support it. So I have a comment in here, and it just doesn't fit because I've kind of made this font larger. But it says that if you want to do that, they are well aware of this in the Babel team, and so they provide a browser polyfill script file, and that will patch up the objects in ECMAScript 5. And in ECMAScript 5, in any JavaScript engine, you can say, oh, here's the arrays object. I want to add a new method to it. So their little browser polyfill adds the from method to array. And that way, you can run the feature that only exists in ECMAScript 6. Are you starting to feel like there's a lot of edge cases? There are a lot of edge cases in going to ECMAScript 6. So a couple things come out of this. Number one, do you really want to support every single new stinking language feature? Probably not. Do you want to go to ECMAScript 6 right now? If you have a need, you could. Would I say everyone has to wholesale move over? No, I would never say that. It's kind of like people choosing CoffeeScript versus JavaScript. They wanted more productivity and less syntax errors. I think with the JavaScript ECMAScript 6 side, it's I want to go where they're heading. And I've got a longer term project. I know I have time. I can work with this. They are approving the ECMAScript 6 languages. Alan Worsbrock said for 2015 used to be ECMAScript 6. What is it? By June it will be actually finalized. It's pretty much finalized now. So the language shouldn't change much, if at all, for the foreseeable future once that's frozen. And you could start using it. But it's not something I'd rush and say, look, everyone, it's coming, it's tomorrow. It's the same message you had with HTML5 a couple of years back. It's coming when all your customers are able to get to it. So you could do this in the meantime and get ready for the eventual switch over. All right, let's keep going here. So that's the interactive API. And all I did was I just put a script on the page. I loaded the browser JavaScript file, which is the browser in-memory Babel transpiler. I loaded the browser polyfill, and then there was a shim for another feature that I can't remember off the top of my head. But those are the three things that I had to load up. And then, as long as I mount scripts and I say that their type equals text/Babel or Babel, it will automatically transpile those scripts before it runs them. So that's one way you can run Babel in the browser real time. They don't recommend you do this because things like modules have to go through a translation phase, and they want to pick a technology for loading modules like AMD or Require or JSPM or something, and they're going to do that translation to some code, and it might not work unless you have everything ready to go. So they don't recommend that you run the in-memory transpiler for much more than small projects. Be careful about doing it for libraries. You're probably better off running it through a compiler, a transpiler. Okay. So this is the other way to do it. When you do an npm install at the global level of Babel, you get in the path a Babel command line, and you can put a file on that, and it will output. It's a standard output by default. It will output the transpiled version. So that tells me that great, now I can use that in the build, and that's exactly what you end up doing, right? So you could certainly do this in the command line, and we could get fancy here, and we could let me see if I have it here. So I could say x equals 23. It didn't work. Well, never mind. I could pass it through a file and run it. It would just spit it out. It's not very exciting. It's the same stuff that you would see in the other example. So how can we do a build system to deal with Babel? Okay. So clearly my Vim is not configured correctly. So the first thing was the playground. If you wanted to look at the samples, the playground was the one that ran it interactively, and it was just a little Angular app because I had an excuse to write an app that then ran the in-memory transpiler of Babel. Babel build here, we've got, let's look at the gulp file. So I'm using a plugin, actually I'm using a couple plugins here, and we'll kind of step through them. One of the plugins that I'm using is, I wanted to make it so that every time I make a change, it would automatically reload the browser. And you could use live reload. Has anyone here ever used, what is the tool that I'm using here? Browser Sync? Okay, you're in for a little bit of a treat. And I say a little bit because it's a demo and it could go terribly wrong. Let's try that. So let's do Gulp web server. Oh. Like I said, it's a demo, it can go wrong, so let's make it go wrong. Stop that. Kill that. There we go. Yeah, I ran on 8080, fighting myself. Okay, so what's going on here is just silliness, but on 3001 is Browser Sync. So it's a free open source tool. It's an npm install Browser Sync, and you use it kind of like live reload. And you communicate with it whenever you want to reload something. The nice thing is that it will find all the clients on everything that's running Browser Sync and reload them all. So this is great for mobile developers, for example. So you're doing mobile web apps, right, on Ionic. That guy there. And so you want to be able to just quickly test the change to a page on the browser. So you set all your browsers up, you want to live reload them, you hit a button, and all your phones flip to the new view. And you do it from that console right there, or from triggering it through a build. So that's an interesting little side tool if you're curious about keeping your code running and refreshed automatically when you hit save. It's an option that's additional to live reload. It's called browser-sync. So that's one thing I'm using in this example. Let me go back to the code. But let's look at this build and see what we're doing here. So the first thing is I'm running a web server here. I'm running a Connect web server. It's a real lightweight web server for Node. Browser Sync actually allows you to proxy calls to 8080, which is what I'm running our web server on. So it will give me a port that I can communicate with, and it proxies the calls. And if I decide to live reload, it knows who came through, so it can communicate back with a WebSocket. That's kind of nice. I'm using Gulp's watch to watch the source code. And what I'm doing is I'm putting my source code that's not transpiled yet in source ES6. So along the left there, that's source ES6. And that is my ECMAScript 6 source code in its native format. I'm watching that code, and every time it changes, I trigger something called JS Watch. JS Watch, and this is the way Gulp works, is basically it lets you watch files and lets you pipe files through processes. It's a build tool. And so whenever the watch is triggered, it says, well, I've got to start by doing the Babel compiling. Oh, and then when I'm done with that, call reload on Browser Sync. And that causes all the clients connected to Browser Sync to reload themselves. Okay, so everything just automatically reloads. Meat of it is over here in Babel. Now this is where Dave Thomas today was talking about all the tools that he was working with, and I was just shaking uncontrollably with laughter because at the end I ended up with Gulp and Browserify. So I was one step behind him. I was looking at the other stuff he was talking about, like, I've got one day, and I gave up on it. But I went through a bunch of gyrations to get this to where it is now. Let's just say that there are 10 different ways you could do these transpiling processes. Pick your favorite build tool. There's probably a plugin that will basically support what you want it to do by calling either Babel or this later thing we're going to talk about, Traceur. And there's all sorts of different ways to reload them, to concatenate them, to do minification, whatever you're looking for. But this is one way, and I'll explain the benefits of it as we look at it. All right. So Browserify, I was avoiding that for months because it was just yet another technology I didn't want to try to learn, and the documentation wasn't all that helpful for me. But I found a really good blog post as I was struggling with putting together the build that said, here's how you put together ES6 with Browserify, and it clicked for me. Browserify works this way. It lets you install packages with NPM. So you're loading things with NPM, and that's the Node package manager, and things go into the Node modules directory. You can then tell it on a build step in a tool like Browserify to take all those things and turn them into a stream of JavaScript that it can then minify and process and output as one file to the browser. So Browserify these libraries down to a stream that turns into a file, which is really nice, actually, because as long as it's fast, and it is fast, then you can just have one simple source file to refer to when you load everything up. It also does source maps. So for example, if you want to know what the actual file was, where it started, it can point back and say the error was really over here. So it's a very powerful tool. But by itself, all it's doing is just concatenating and eventually potentially minifying the stuff, not doing any ECMAScript 6 to 5 transpilation. But they have a plugin to it called Babelify. So Babelify hooks into Browserify in a step of the process and does the transpilation as it's working through the files. So that's what we're doing. On line 30, we fire off Browserify. We say that we're loading this particular entry, app.js, and of course you can put a path in there if you want to. I'm just using debug to see what's going on. Browserify then has a method called transform where you can pass it one of the transformers. And so one of the transformers is called Babelify. Then you can bundle whatever things that came in through this process into a file. And you can say that I want to pipe it into a thing called bundle.js. Strange that the name is called source, by the way, but that's the way it works. And output it to this destination. So generate one source file called bundle.js and put it in www.js. Now the cool thing is when you fire up your tool, you start your web server, now you're in this constant watching mode, and every time you hit save on the browser, if you hit save on the editor, it's going to automatically kick off the reload after it transpiles everything. So it transpiles, drops the new file in there, and all of a sudden your page reloads and the code is reset. Really, really nice little workflow. And again, that's one way to do it. You could do this with live reload. You could do this manually if you want to and just say only when I run my build do I transpile. What I've been doing, and I've seen a couple different approaches, what I've been doing is I've been putting things in a source directory, and then that gets transpiled into a JavaScript directory to the www directory in your web browser directory, right, where your file will be. Others have done things like the source file is .es6, and then it transforms it in place and removes the 6 from it, and the new file is a transpiled one. I am too concerned that I will edit the ES file or the JS file instead, and then forget it and overwrite my changes and kick myself in the head. So I would prefer to separate the files because I'm an old Java guy and I like Maven and separated directories. Just me. So this is nice. Another case comes up, what do I do about testing? All right, I like using Karma, mostly because I've been brainwashed to use Karma by the Angular team. There's nothing wrong with that. I like Karma, but that's my tool of choice. And I know there's some other solutions out there, right? But Karma is a nice test runner. So here's my way of running unit tests. Now, Karma is just a runner. It just kicks off testing tasks. And you configure it to whatever testing API you want to use. And I'm using Jasmine. That's what the Angular team mostly uses, and Angular programmers usually use. It's not required, but it's generally what you'll end up with. And I'm using karma.start. So karma.start, if I kick off gulp space test, it will fire up Karma, and it will take it through one pass. So it points to a config file. That's the standard thing with Karma. Karma then says, where are my instructions to run the build? And what is the action I'm doing? I'm going to run a test, and it's a single run. And then there's a little thing about calling a callback when it's finished to know that gulp is finished. There's a little bit of syntax there. That's running it in one-shot mode if you want to do it like in a nightly build or whenever you commit. But if you want to do it every time you hit save, you can run TDD. That's just another example of it. And I don't set up single runs, so it's always continually running whenever a change is made to the files. And then every time I hit save, if the source changes or if the test changes, it reruns Karma. So my unit tests are always being executed every time I hit save. But that's not the ES6 stuff, right? The ES6 stuff is the stuff that's hiding inside of karma.conf.js. So this is where the ECMAScript 6 code is, the translator. The Karma runner is just a JSON config file. Or I just say a JavaScript config file, it's not JSON. And so in frameworks, you normally put in Jasmine or Mocha or whatever you're using, QUnit. And you can also add Browserify to this. So now I can use Browserify to kit up and transpile my tests during test time. So I can write my tests in ECMAScript 6, transpile them down to 5, and then run them. So this is one way to do testing. And remember, the thing about unit tests, if you're doing web unit tests, is they've got to run in a real browser. Right? So I have to do something like this, because when my Karma tests run, they run in a browser. It might be an in-memory browser like Phantom.js, or it might be Chrome or IE or something else. But in order for it to actually physically run, it's got to run ECMAScript 5, because almost every browser doesn't support ECMAScript 6, right? So if you're doing Karma tests against the browser, you've got to transpile if you want to write them in ECMAScript 6. And that's what we're doing. We are just simply saying that we're using Browserify, and then we list the files we're pointing to. In my case, I don't have any libraries. It's a real simple, dumb application. So the source code, my specs, and then I use preprocessors. So Karma has a preprocessor API, and you can hook in Browserify. And so the deal is you say preprocessors, and for each path you get to pick the list of processors that you want to use. The one that makes sense here is we're going to use Browserify. We're going to pull everything together into one file. And then we're going to tell Karma that's the file that you want to use when you run your tests. Same thing for my source as well. So there's going to be two files basically that are getting streamed into Karma. But then I get to tell Browserify what my settings are. And in the setting of Browserify, I also use that same Babelify translator. And now I've got the ECMAScript translation. So you look at all that and probably think, I could not figure this out unless I pounded my head against the wall. That was my job for the last 3 weeks, 4 weeks, was getting something to work in all these little things. So if you've done it already in a different way, you've done what I've done, which is basically bump your head against the wall because there's no good documentation. It's all in blog posts and people talking to each other. But it will come. Over time, it will get better, and things will standardize. But that's a nice way to do it, is Browserify. Another way to do it is just manually do it, where you run that Babel translator for your test and a Babel translator for your source, and you manually run it before you run your tests, and you manually run it before you run your web server. That's a simpler way to do it, and just do like a one-to-one compilation. So there's a bunch of ways to do it, but this is one working mechanism. All right. Good, it's loaded, so I don't have to worry about it dying. I shut down the server. Okay, so that's the Gulp project. Now, if you want to run Babel from the command line or Babel from the command line, you can do that. If you want to see all the features that Babel has, you just do -- help. And one of the sections of -- help is called transformers. The way it works is each of the major ECMAScript 6 features, and then 7 features as well, because they're looking down the horizon of what's coming in ECMAScript 7, and then eventually 8, and so on. Anything that is going to be on by default does not have brackets. So you can turn off a feature by filtering it out, which we'll see in a second. And you can turn on a feature that's bracketed by just including it in the command line. So Bluebird coroutines, whatever that is, and I don't know, is not on by default. You can turn that on by adding that as a flag to Babel as you're running it. And of course, all these Babel plugins let you pass flags, so you're going to do the same thing there too. So you'll want to look at the Babel docs and look at the options in Babel to see what these different features mean. But you can find out what ones are supported just by doing Babel -- help, and it will show you. Here's how you remove one, blacklist. So I can blacklist a particular transformer or two. I want to get rid of ES6 spread and ES6 regex Unicode. And then it won't do those transformations for me. Or I can whitelist ones that aren't on by default, right? And ultimately, the goal would be, as eventually all your browsers go into green territory, you don't need to transpile that feature anymore, so you turn off the transpiling of a particular feature. That seems to me to be a lot of low-level work, but here's the reason why you want to turn some of these features off. If you're doing some feature that requires like a real replacement of the guts of JavaScript, like a tail recursion. Tail recursion is the ability to not use the stack when doing a recursive function, right? It's a way of almost like doing loops. And so to do that in JavaScript now, they basically have to generate basically a recursive function. So although it lets you look like it works, you blow the stack. The only trick is I think Babel lets you, as long as the function that's being recursed is the exact same function you started with, if it's the same function you're going through, it can do it with basically almost like a goto, and it won't blow the stack. But if it's another function you're doing it with somehow and it can't figure out it's the same function, it will use the stack and you're out of memory. So once it actually supports a native feature in all your browsers, you want to turn off the Babel generation and make sure it still works. You could be waiting a while, right? Depends on if you have IE 9 or 10. Traceur. Same deal, by the way. We can kind of save a lot of time by saying almost the same thing, different team, and it generates slightly different output. But we'll just talk a little bit about it. So Traceur, the one thing about Traceur that's different, it's the Google team's been working on it. So I believe it's the V8 team. Am I right about that? Is the Babel team, or the Traceur team part of the V8 team, or they work with them? Yeah, I'm not sure. I thought I heard that somewhere, but that's true. We should probably take a couple seconds to talk about that too, just to say where these things are. And I have a little note on AdScript. So anyway, so Traceur is another compiler, and I actually put it second because I think Babel is kind of the way things seem to be going. It seems like it's got a lot of adoption, and it seems to be the one that has a lot of features in it and a lot of ways to run it. But this is a very similar thing. So you could load Traceur and its bootstrap in memory, and then everything that's mounted with a type of module will transpile. And they also don't recommend doing this because it's not real practical. Or the other option is to use it as a command line. So there's a Traceur command line and the same kind of thing where there's options to turn on and off. You could find plugins for a lot of different platforms like, Traceur for Gulp or for Grunt or who knows. Browserify has one that was called Tracerify, but they've changed it to 625ify, which sounds like, Babelify. Just so you know, Babel is the new name for a tool that used to be called 6-to-5. And, JS 6 to JS 5 or ECMAScript 6 to 5. And so I have a feeling that they decided to kind of push that direction. I'm not sure why they called that name that, but that was the old name of the Babel transformer. It was called 6 to 5. Now, because they're doing more than just 6, they call themselves Babel, and 6 to 5 is kind of gone. So very similar, uses. Karma also has a Traceur post-processor, or preprocessor, I should say. So I don't want to spend much time on Traceur, but I do want to spend just a little bit of time on where Traceur kind of fits in the world of like Angular, things like that. So just want to get a notepad up here. Now, I'm probably going to get all these annotations wrong, but because I think, didn't you say they changed some of these names? So I'm just going to do something like this: component, template, and then class, foo, constructor, blah, 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 me, you, fun. So, in other words, in Angular, they're going down this road of using annotations. So annotations are just metadata that describe the need or the feature that's going to be supported by a particular JavaScript class in the Angular world. And so these little annotations here, these are a proposed change long-term to ECMAScript. They presented it to TC39, which is the standards body. They said, we'd like to be able to decorate classes with annotations. If you've done any Java, this is going to feel very like deja vu, because Java is all about annotations and .NET also, right? Like, where are we coming from here? They're all enterprise developers probably. This is one way to do it. There's a couple of other ways to kind of decorate classes. One called decorators, and I know Yehuda Katz from the Ember team presented at TC39 a couple months earlier about using that approach for metadata as well. So they may have said that they've submitted this to TC39. They proposed it to TC39. It could be in ECMAScript 7 or 8, but right now it's a proposal. So they know that's not going into ECMAScript as a language right away, but they wanted to build Angular in a way where they could kind of decorate components very easily and say, here's a component that's going to end up on a page, here's a template file it came from, and then I could route to that named component called class foo, and it would automatically know, oh, load this file and run this JavaScript. Neat little way to do it, right? But this doesn't exist in Babel because it's not a feature. And it certainly doesn't exist in ECMAScript itself because you can't compile to it. So the Google team on Angular worked with the Traceur team and came up with an extension to Traceur, which I'm not sure how it works, and it's kind of changing anyway, so it's kind of, I'm not going to show it to you because there's no easy way to show it. They came up with an extension called @script, AT-script. And for about 6 months, maybe almost a year, @script was the name of the preprocessor or whatever it is inside of Traceur as an extension that could take and send this metadata down the line and turn it into something they could work with. Back in March, we were at NGConf, the Angular conference, Salt Lake City, highly recommended, great destination and good conference if you're an Angular person. And they announced that Microsoft TypeScript, which is kind of an extension to JavaScript that lets you do things like this. So let's say I've got a constructor. I can say, now in JavaScript, this is anathema. Constructor, name, string, a type. Not a type. Yes, a type. TypeScript, its whole reason for being was to give a little more information in the declaration of JavaScript code. It's a preprocessor like CoffeeScript or something like that. And what it does is it allows you to use types and generics with brackets around variable types. So I can say I've got a list of strings, which is a great thing when you're writing a large amount of code with a bunch of people because you want to get the types right. They've now worked with Microsoft, who creates TypeScript, and TypeScript is currently at 1.4. 1.5 will have support for all these annotations. So they are moving down the road of saddling up to Microsoft and adding the features that aren't yet in ECMAScript 6 that they want for Angular into TypeScript. So that at least there's a open compiler that will generate the metadata they need for Angular 2. The reason I mentioned any of that stuff is we were talking about @script and Traceur and all these things. Traceur might stay around in the form it's in. @script is going to get folded into TypeScript. So the other thing you ought to at least keep your eye on if you want to go down the road of Angular 2 is you want to pay attention to TypeScript. Because TypeScript 1.5 is going to have all the support for this. Plus, there are all sorts of, we saw a really cool demo. They were using Sublime Text and hitting Control Space, and it had code fill-in features. Because it could read those annotations and say, oh, this is a string and it came from this property, so here's an option for you. And you're using like a lightweight editor to do code filling. Really interesting concept. So if you're doing Angular 2, you want to track TypeScript. That's what you're going to end up using potentially if you want to do the full tool chain. Kent?
I just think it's good to know, and Angular keeps reiterating this, you do not have to use any build tool at all.
That's right. And yeah, just to make no FUD about it, right? I want to point this out too. Thanks, Kent. If you're going to go down the road of using ES6, then you do have to use the build tools because you're going to generate code that won't run in a browser. But actually, Angular 2 will ship as an ECMAScript 5 compatible library. And you could write ECMAScript 5 against Angular 2. So you don't need any tools. You could do it the same way you're doing it now. But if you want to take advantage of the same thing they take advantage with build Angular and get type safety and get metadata, then you will want to use TypeScript. That's just my opinion on it. But they're giving you the option to go fully up to that new way of writing code or to do it the same way you're doing it now. Now, the code will look different because it's Angular 2 and not Angular 1. There are some significant differences. But it will still be ECMAScript 5 compatible. It's just that if you're going to code in the ECMAScript 6 syntax, you'll probably want to look at LiveScript, or I'm sorry, TypeScript 1.5. Yeah.
So TypeScript you use with ES6, but there is no ES6.
Yes, let me explain. TypeScript TypeScript 1.4 generates ECMAScript. This is crazy. TypeScript 1.4 generates ECMAScript ECMAScript 5. So it works against the current browsers. If I'm correct about this, and someone correct me if I'm wrong here in this group, TypeScript 1.5 is going to start generating ECMAScript 5 or 6. Am I correct? I think I'm correct about that. Roughly. And we haven't seen it yet because it's not even in beta yet to look at. But I'm pretty sure when I heard them talking about it at ngconf that they said that it was going to be able to start generating ECMAScript 6 classes and things like that, so you could stay in the ECMAScript 6 toolchain if you want to. So, but not TypeScript 1.4. The current version only generates ECMAScript 1.5, and it will not do these things. Okay. So the Angular team is basically moving from Traceur and that script to TypeScript 1.5 for their internal development of Angular. Okay. So I know that's a lot of stuff, a lot of terms, but there's a lot of movement right now in the JavaScript community. It's very similar to the Java community from 1.4 to 5 when they went to generics and annotations. It's the same kind of like everything is changing. The whole world of JavaScript is changing in a tectonic way, and there are a lot of frameworks that are looking at that and saying, how can we take advantage of the features? Should we? And building tools around them. So it's in flux. And again, some challenges would be that the generated code may not be exactly what you expect it to be. So the first thing I would say is you want to start writing tests as soon as possible if you're going to do transpiling. Test the transpiled code to make sure it does what you expect it to do. You know, unit tests are a good idea wherever possible. Make sure you test them against the browsers you're looking for. That example of array.from not existing unless you put a shim in the browser, it's a little bit of a gotcha. You know, it covers a lot of those cases, but you need to know about that. So you want to test all this code a lot. And again, that's where that polyfill comes in. And it's not going to fix everything. First of all, one thing you have to deal with transpiling is, and it's a good thing long term for JavaScript, they're implementing a standard module system for breaking up your code. Now, Java's had jars and packages for 20 years. JavaScript, no one ever standardized the package system, so you've got require, AMD, all these loaders that have come about ever since ECMAScript 5 or so. There will now be a standard module system in ECMAScript 6. And it's relatively straightforward. You put a file out there, you import from that file, and anything you want to export, you use the export keyword to export from that file. So it's export to make it available, import to load it. Relatively straightforward, but here's the problem. If you write ECMAScript 6 code and you use all those features, and then you go to use it on an ECMAScript 5 browser, there's no module system. So you will have to make a decision early on, and you can change it, but changing it requires a fair amount of testing. What do you want the transpiler to generate your modules in the real world of ECMAScript 5? So for example, in Babel, you can turn on a switch that says when you generate modules, generate them as AMD module code, generate them as system.js module code, generate them as require calls. And it's a little flag that you set that has big implications, right? So obviously when you load your browser, you've got to load a module you got to load a module script and configure the module system and make sure that your transpiler is generating the right modules for you. Right, so there's some gotchas there that you'll have to deal with. And you want to use the module system of ECMAScript 6. It's a very useful thing. Helps you break your code up. I already mentioned about the tail recursion. There are some changes you just need the browser to catch up. So as you're checking these things out, you might find that it's not going to perform until you get the real version. So test that. And some of those APIs then won't be available without a polyfill or something like that, like the from. And check that Kangax site. The Kangax site is kind of interesting. It actually runs its entire suite against your current browser when you load it up. So you'll see it chugging away. And the first column, I believe it is your browser. So you get a feel for what you support. Kind of interesting. All right, I already covered this. How long do I have? 1 minute. We're done now. 20 seconds with server side. So Node.js, couple ways to run Node.js in ECMAScript 6 mode. One way is to use Babel and Transpile and just run against ECMAScript 5. Another way is to run node-babel. So when you install Babel globally, you get a wrapper script called node-babel, and it kicks off the right settings to run ECMAScript 6. Or you can turn on options. So for example, -- harmony turns on all the ECMAScript 6 options, and then you're running ECMAScript 6 inside of Node. You can also say -- v8 options and it prints out all the options you have. Because Node is basically a wrapper around the Google V8 JavaScript engine, which supports some of JavaScript 6, ECMAScript 6. So then I can do Babel node and arrow function or whatever, and I'm almost done. The other option is you could look into io.js. io.js is a fork of Node.js. The group of people that did that felt the joint wasn't fast enough in responding to their needs, especially around ECMAScript 6 adoption. So they did a fork. There's a very tasty set of issues. There's an issue 1336 from there that is a big, long discussion. Should we go back? Should we fold back into the Node branch? And his opening statement was, no, we shouldn't. And then it was a very interesting set of exchanges. But it almost works the same. So I'm out of time, and that was pretty much where I was going to end up. So on the Node side, you just flip a switch, and you can start running in ECMAScript 6, or you can transpile. If you have any questions, see me after the talk. Otherwise, thank you.